Good morning. My name is Neil Nere. I'm with Efficient Automation Services here in Houston, Texas. And the purpose of starting this channel is going to help out all the guys that do Honeywell WEBS, Johnson FX, and a couple other Tridium products to give us all the ability to talk to each other, communicate, and also look at some things that we all may be having some issues with or troubleshooting ideas, some techniques that we can all share with each other. But I guess let's go ahead and get started. Once again, like I said, my name is Neil Nere. I'm here to talk about and discuss some of the benefits and benefits of why an open automation system is, I wouldn't necessarily say better, but better for the end user, to where the end user has full control on who they want to use as a vendor, and give them the ability to have much more competitive pricing versus where you have one or two companies that can operate on your system, and they can basically set the market at whatever cost they want and charge you a lot more later on in the long run. Sometimes their initial installs are fairly low, but they're going to get you on the build outs and the items like that. There's already, their program basically means that over the next 5 to 10 years, they believe that the customer is not going to get away from them and will basically make anywhere from $500,000 to $5 million, sometimes $10 million per building. Just depends on how big your location is. Because I mean, that's what they do, and they charge per point versus where a company like myself, we'll look at the existing, we'll look at the floor plans, look at what's existing, and then we price based on what it's going to cost for labor, materials, any software that's needed. For example, floor plans, things like that. We do a lot of custom 3D floor plans, custom 3D animations for the equipment to kind of represent what's there, so that way the engineer or whoever the end user is can get a better understanding of what's going on with their piece of equipment. But so I've already typed in Platt install daemon, and I've already loaded everything. So I'm gonna go here and type in my WB to bring up my workbench. I'm using 4.8 for the Honeywell WEBS right now. So I'm gonna minimize that, and I'm running a dual screen, so some of my stuff will pop over to the right. I'm sorry about that. So we're gonna go here and just go to one of our stations that we have remote access to. Just makes it easier to work on things. So anyways, we're gonna do just a basic air handler program today. Show you guys how to build it from scratch. And then how you can expand on it based on the application. So anyways, here I've already opened up the station, gone into drivers. It's a BACnet network. And then here are my controllers that I have right now currently on this little system. But I want to bring in a new controller and create a chill water air handler program. So you go up here, here's your palette, you click on palette, and then it'll bring up this sidebar over here for you. Click on this. We're Honeywell, so sorry. So here's all our Honeywell modules. We're doing the spider tool, which is already over here on the right, on the left, sorry. We're gonna drop in a new controller. We're going to call this AHU _01. So what we would like for you guys to do is if there's any special requests or anything you guys would like to see, please leave a comment in the comment section, and I will be more than happy to bring up maybe that specific idea that you guys are having, or question or task, and we can build upon that. Between myself and my guys we've always, we're going to go into engineering mode, and that's how we get to our wire sheet. But there's not really a lot of tech tips out there when it comes to the YouTube for guys like us. I mean, there are some things, but I feel like more specific, this would help out with the guys that are doing Honeywell WEBS, Johnson FX, some Tridium other products that are out there. This is pretty much the basis for all of it anyways. So I added the controller. If you want to do a tab, you just push Control T, and that brings up another tab for you. And then I want to make sure that I'm doing a 6438S for the device model. So let's get started on writing a simple basic air handler program. We got our physical points, which means that's our AOs, our DOs, our DIs, our BI, anything that's modulating, modulating input, modulating output, universal inputs, temperatures, static pressure transducers, all this stuff that along those lines. Our software points are going to be our network set points, network inputs. I really don't use constants that much. And then you have your network output, which basically is just showing you what that point is. So let's go ahead and get started on, like I said, with a basic air handler program. So we're going to start off with our current state. We're going to configure the properties on that. Go to configure properties. I'm going to bring the screen over here. So we're going to leave it a set point. We're going to make this unitless. And you can stay with the valve float, but I'm going to go with the occupancy, which is click OK. Then I want to duplicate for later on our next state, which if you ever want to get into building optimization, that's where this really comes in handy. So we're going to take our select block, and this is going to be for occupancy. So we'll go to configure properties. I'll bring this over here. Our default, make that a constant. I want our default to be occupied just in case for some reason something happens with the program. It knows that, let's go ahead and stay occupied. Constant 0 is going to be a 1. 1 will be a 0. So that way, meaning that when it's unoccupied, it won't send out a command like a true false command. Click OK. I'm going to go down here. We're going to remove some of these pin slots because we don't need them. So we'll take our current state. We'll go into here. So with Honeywell, 0 is occupied. 1, oh, look at that. I made that a 0. So default should be 1 to be occupied. So now, if it fails, it'll fail occupied. 0 is occupied, which is a 1. Then you have 0 for unoccupied. And then this is for bypass, warm up, however you want to set up that output. So we're going to want to do a binary output for our fan start stop. So it'll be fan underscore start stop. What I do recommend for any controls guy out there is to come up with a basic verbiage on what you guys want to use when it comes to labeling all your blocks. So that way you have a consistency across the board, but then you can also save these programs and then modify them as you want to go, which is what we do a lot. We'll save them in a palette for all this stuff that I'm going to be doing with you guys. I will start off with a blank canvas so that way we can all see how things are started from start to stop. So we're going to want to take our output and do our fan enable. This is going to be a very basic chill water air handler program where we're going to do some basic things, and then you can also, like I said, you can expand on it. So let's say, for instance, you have an outdoor air damper. So here's a binary output. We're going to call this OAD. So here's our outdoor air damper. And for the sake of this one, we're just going to start off, like I said, real basic. So when we call for enable, it's going to open up our outside air damper, fan start stop. Now we need to work on a discharge air temp. So for this one, what we're going to do is we're going to do it based on a DAT versus maybe climate control, things like that. So we're going to do our modulating input. We're going to call this DA temp. So we're going to go here, go to configure properties. I'll bring this over for you so you can see it. It's going to be a 20K sensor. There's the TR20 series, which is the normal zone temp sensors, but everything's going to come in as a 20K. And then we like to set these up for Fahrenheit. Click OK. And there we go. So now our DAT temp is set. Then we're going to do a network set point. We're going to call this DAT_STT. We'll go to here, configure properties. The pop-up screen brings it over here. It's already set up for temperature in Fahrenheit. And let's do 55. Later on, I could show you how we could do it a sliding discharge air temp set point based on outside air temperature. Here in Houston, we have a little bit different weather versus just like anywhere else in the country. We have a real large issue with our humidity here, so we have to do a lot of things that to take that into account. So we have our discharge air temp, our DAT set point. Then we're going to need a binary input. We're going to call this fan status. So basically what we want to do is we want to make sure that our PID is being enabled when there's a fan status. So since our fan is being command based on our occupancy, our current state, we can bring that in and do an AND block where we say if we're occupied and our fan status is going. But what I like to do is I like to do it based on fan status. So let's say, for instance, there's an issue. I'm sorry about that. Let's say there's an issue and the controller, communication between the controller and maybe a Jace are down. What you could do is you can at least get the fan running, and then it'll start doing all its sequences and stuff like that to look on fan status. So we have our DAT set point, fan status. And let's go ahead and grab ourselves an OR block. And I like to call it a knot. So in order to enable our PID, what we're going to have to do is you're going to have a 0, because when you do a 1, that's an enable. So what we're going to do is we're going to take our output and we're going to make it a negate, meaning that it's going to be the opposite. So if it's true, it's going to basically say false. And you can use it for a lot of other things. So then we're going to take all these pin slots out that we're not using. Here's our PID. Like I said, we're just doing some real basic stuff here. Not going to go into nothing crazy for the first one. And then as we go, we can add and we'll show a lot more. And I'm just trying to show people how to look at things to make it easier for you later on in the future. I'm real big on when we do things, we look at it based on service. So let's say, for instance, I got to go and service something. That's why I try to keep my sheets real clean and pretty organized, so that way you can see the flow of all your lines. Later on, we can get into macros and applications, things like that, to where you can condense things and then you can kind of jump around and see what's going on. Basically the same thing you see with when you bring in the Honeywell BACnet apps or lawn apps. You can actually go into the programs and you'll see that they have them all in applications, and you could jump to different sections and you could find the hyperlinks and so on. We actually had to repair an RTU program that was based out of a can, where when it went to looking at just the TR40 silk bus stat versus the TR 70s, where it's got displays on them and things like that, it actually broke several links, and we had to go in there and do right here, which is debug, where it brings everything up live and you could see what it's doing. And the issue was it would not change between heating and cooling because there was nothing there to show the mode. And what it was is, on their program, it shows all the set points, and then it all goes into a block, and then that block then goes to another one, which is a pass-through, to show that the different set points and based on occupancy, to show the different mode, to say, okay, I need to go into cooling, I need to go into heating, or I just need to go back into, just hanging out and not doing anything. So anyways, with our PIDs, since our PIDs are, it's called CLG. We're going to call this _THR. And that's our throttling. So with our PIDs, I always tell everyone, we're not doing process control, so there's no reason to really get super tight on a PID. All your PID is trying to do is, you have a sine wave that goes up and down like this. And what you're trying to do is once the air handler starts and you're trying to control your PID, you're trying to level that out to where it's going slower and slower, and it becomes more of a consistent line. It's just going up and down like this to maintain, and you don't have that big sporadic. So we have the cooling throttle and range, duplicate, and I like to do the integral time. So we're going to configure the properties on these. So throttle and range, configure. I'll bring it over here. We're going to make this unitless valve float. Like I said, I like to try to I have a pretty consistent basis that we like to start off with. So we normally start off with around 8 to 10, depends on what you're trying to control. For this application, I'm going to do an 8. Usually with static pressure transducers, things like that, we'll start off with a 10 and we'll modify it as we go. Also, another reason we make this a set point is so that way it makes it easier to commissioning. So that way you can make your adjustments, because if you made this a network input, you won't be able to make the changes as easy as it would be to do your configure. So then our set points, my bad, I'm sorry. So we're going to change this to time. Go to seconds. And depending upon, we always start about 150, 200, sometimes 300. It just really depends on what we're trying to control. Like I said, we have a real basic start off, which is what we're used to because we've been doing it you know, for a good while. So here we go. So we have a basic PID set point where we have our discharge air temp sensor, our discharge air set point, our fan status, which will enable. So that's why it says disable. So if it went true, it's going to disable the PID. You have your cooling throttling range, your cooling integral, and then here's our output. Now with Honeywell, this output will go -200 to +200. So what we do is we'll put in what's called a limit block, which also helps out. So we'll take our output here, put it in the X. Then we're going to go to configure properties. I'll bring this over here. Our high limit, let's make it a constant. Make it 100. Our low limit, we're going to make it 0. So that way when you have your output, you're doing 0 to 10, 2 to 10, whatever you like. This is the easiest way to do it to maintain that consistency. So for this, we're going to do a modulating output. We're going to call this chill water valve _ chill water valve command. And that's going to be our AO. We'll go to configure properties. Not saying all the different brands have different ranges. We do a lot of Belimos and a few other products, but mostly it's a lot of Belimo product that we see out here in Houston. So it's a 2 to 10. Obviously, they come 0 to 10. The ones that are always on the shelf for us that are available are the 2 to 10. But the cool part is you can modify this to whatever you want. Could be 0 to 5. I mean, we've done a lot of water plants where there's some different type of actuators and meters and back flushes that do different voltages, where this all comes in super handy. Here's our advanced. If we need to change any of this, which for this we do not. So we have our 2 to 10 set up. Then we go here. So like I said, this is just the real basic. Let's get started. Here's a chill water valve command. You can modify this to where we do humidity control. So let's say based on our humidity, we want to go ahead and we want to open this to 100%. So what we can do is we can take our chill water valve command. Let's grab another select. So I'm just going to, since I already have one here, I'm just going to duplicate it. I'm going to click OK. And this is just to show you how we can expand upon it. I could literally go on and on. The thing I will tell you guys is for, there are so many different ways to program. Everybody has, 4 or 5 different ways to program something. We want to go into default, and then we want to go into 0. There's probably, let's say 10 different ways to get to the same product. What I'm trying to do is just try to give you guys real basic information and then build upon it, get your own unique style, and, do what works for you. So I'm going to delete this link to the chill water valve command. What we did is here we have our default and our 0. So basically when when the humidity is not being called for any kind of control, it'll be controlled based on our discharge air temp PID. So what we can do is we're going to do a network set point. I'm going to call this humidity set point. All right, so we're gonna go configure. I'll bring this over here. Do a percentage. And we're gonna say anything above 60%. But the good part is we're making it adjustable. So if they want something tighter, 50, 55, for comfort's sake, that's where the humidity set point comes in really great. So then we need a modulating input. I'm going to call this, I'm just going to call it humidity. We could do humidity, zone humidity. Let's try and keep this real basic for right now. So we're going to go configure properties. Like I said, I'm just trying to show you guys some things. We can expand on it more and more as we go. So we're going to do, ours is going to be custom voltage. It's going to be percentage. We're going to say 0 to 10 volts, 0 to 100% on the humidity. Click OK. There's one thing I wanted to check on this. Okay. So you can change these from normally open to normally closed based on whatever type of CT airflow switch that you're using for fan status. For an air proven switch, we'll call this air proven to show that versus a fan status with like a CT. So right now we have our humidity set point. And what we're going to do is we're going to grab ourselves a compare block. So we're going to take our humidity, our output, go into input, and then our set point here. So basically what we're going to do is we're going to go into configure properties. We're going to say if our humidity is higher than our set point, then we're going to be enabled. So there is an on and off hysteresis, which means that you can do it based on a value. So let's say your humidity is kind of fluctuating a lot. And this is just for humidity. You could do it on everything. Where let's say you want to make sure that it's, 60, that once it hits 60%, you want your humidity control to come in, but you don't want it to turn off until it gets down to about, maybe 4 to 5% lower. You can do the off and then just do 5, which that way the PID this compare block is not just bouncing on and off. Just depends on what you're trying to do. So what we're going to do is we're going to put it right here into the X. Our X is going to be what enables all this right here, right? So then we're going to take, this right here, configure, we're going to duplicate. So we're going to take our humidity. We're going to call this CHWV. So what we want is when the humidity is getting high, we want to go ahead and just open that chill water valve 100% no matter what. But the good thing is we can make this adjustable and then go on from there. And then we take our output and we link it to our chill water valve. So now we have a real basic program for an chill water air handler. And we can modify it based on if it's trying to do just space temperature control, where we're not necessarily doing a discharge air temp. We're doing the chill water valve based on space temp. And it really just depends on the different application, what the MEP is trying to design, and we modify it from there. That's why I love the Honeywell product so much. It gives us these blank canvases and allows us to do whatever the MEP is asking us to do in the long run, and makes it fully customizable, because then you can run across some situations where canned programs just don't work. I could tell you Johnson, a lot of their stuff is canned and becomes a little more tedious because of that fact, and they over-engineer a lot because they try to build their programs for basically every type of application. So a lot of times we use a lot of side loops and things like that when it comes to the Johnson product. I'm sorry, I keep hitting this thing with my foot. So we can go into here. Also, there was something I wanted to show you guys in the PID. There is the action for the set point. Do we want it to be direct acting? Do we want it to be reverse acting? So basically meaning that for heating and cooling, it changes the way the output of the PID works. So if you're trying to maintain, the proper function for the PID, so we can go here, because our device is offline, I can't show you. What I'm gonna do is I will plug in a controller one day, and I'm gonna show you guys how to go into debug mode, and then you can force values. So we can say, hey, the fan status is true, and then we can see and we can verify that our PID is working the way it's supposed to. But then, so here's just this portion, which is just the chill water. So let's say we want to go ahead and we want to do static pressure transducer on top of that. So what I like to do is I like to just duplicate at least the PID portion. And then what we're going to have is we're going to grab modulating input. I'm going to call this like I said, everybody has their own way of doing things. I'm a big proponent of the underscore. So that way when the point names come in, they don't come in all crazy. And the underscore allows you to use the space. So what we're going to do is we're going to have a modulating input. It's going to be a voltage input. We're going to do, so just for the sake of argument, we're going to do a 0 to 10. It's going to be 0 for the low, and then we'll do 3 inches on here. So now we have our duct static. Let's go ahead and duplicate this. We're going to call this so we have our transducer. So we're going to take our output. Here's our sensor. And then we have our set point. So let's go configure that. Bring this over here. So we're going to do pressure. And I'm going to do 1 inch. Like I said, for the first video, we're just going to do some real basic stuff. I'm not going to go too deep into it. Like I said, I would really like for all you guys to do some comments and let me know what you guys would like to see. What I'm here for is I'm here to help us all out and come up with some ideas and, hopefully help a few people here in the future. So we have our throttling range. So we're just going to keep the basis of all these right now. And that way we can modify it based on when we go to do commissioning and do our report to make sure that our PID is operating the way it's supposed to and it's not overreacting. So for our PID, the question is do we want to do a fan status? So obviously this is going to be on a VFD. We're going to modulate it, modulate our deal on that. A lot of times what we do is we'll set a VFD up to, let's say, 20 hertz for minimum. So that way it's always showing some ideas. So we're going to do just for the, that way it'll allow the fan status to come into play. 15 to 20 is usually where we put our minimums. It just depends on the application. Because if you can't put 15 hertz or 15% on a VFD, and it's going to overpressurize the duct, then you got a bigger issue. So what we're going to do is we're going to take this right here, this knot, and we're going to do it into our disable. So from here, we're going to take this right here. We're going to duplicate it. We're going to call this, that's it. Just trying to keep some things pretty basic for everybody. So we have our output here, static command. All right, so, or let's see, this will make it a little bit easier. Our VFD, do a signal, you can call it output. But I prefer signal because to me, when you say VFD output, that's kind of confusing. Because what we're trying to do is we're trying to send a command to the VFD, for our VFD signal. So we've had some applications where it was an old church, and the church was a couple hundred years old, and they had this $5 million organ that was inside the church, and it had to be a specific humidity or the organ would get out of tune. So the MEP wrote this sequence where the chill water valve would go to 100%, and then what we would do is we would take this VFD signal, and no matter what, the air handler would run at 60 hertz. At 60%. Then this air handler, this particular one for this church, had a preheat and a reheat. So what it would do is it would preheat the return air to get it above the dew point. So that way, as we're trying to draw the moisture out through the chill water coil, it would make it a good return temp, usually around, I think they were trying to maintain around 74 to 70 degrees on the return. And then we would reheat the discharge air temp to maintain the space temp. It was a fun program, and there was a lot of logic. But like I said, there's a reason that I love the product that we utilize. I'm not saying that all of them can't do it. A lot of them can. And the good thing about doing these type of systems is that we can do anything and everything that any system out there can do. I mean, I've put this in process controls. I've put this process applications. I'm sorry. It's becoming more and more popular. I really believe that with the more and more education to the end users, the building owners, management companies, things like that, where these guys start getting trained up on it and realizing that, hey, I don't need to use a system that I only have one option out there. I mean, if you go and you put in a proprietary system, and let's say you spent $250,000, well, you're not going to pay another company to come in within the first year or so after you start seeing the price hikes that you're going to rip it out. And I wouldn't say rip out the entire system, but you're going to rip out a majority of the system and pay another $50,000 to $100,000. It just doesn't make any sense. A lot of people like to hear the fact that, oh, there's there's stability with these proprietary systems. Well, there's stability with the open systems because of the fact that there are the options, and this is not going away. The open systems, this is the future. I've been working on open systems since 2006. I've done Metasys. I've worked on some Siemens things. I've worked on Barber Coleman 8000s. I love pneumatics, and I'm only 40 years old, but that's, what I cut my teeth on when I first started HVAC. I've been an AC guy since I was 16. Started off as a duct installer, then worked my way up to startup. Then I started doing service. The first guy I ever worked for, he started letting me do drawings, and then I started learning how to do J-loads and things like that. And then I evolved into rebuilding chillers, things like that. And then I really got involved in the control side of everything in 2005. And ever since I've gotten the ability, I've ran with it. I guess there are guys with the automation that may not have ever done mechanical work, but have an understanding of what's going on. And you can still be a good controls technician. I'm just more along the beliefs that if you know what you're controlling, you're going to be better. It's just like anything. I always try to tell people, don't get discouraged when it comes to doing automation. A lot of guys will walk up to a controls cabinet and they'll see a big bunch of wires, and they'll just see all these wires all over the place, and then that just throws them off. I always tell the guys, don't worry about the wiring. And what are we here for first? Let's find this. Let's figure out what's going on. Well, the chill water valve is not responding. Okay, well, are we sending a signal? Go to the actuator, drive it up and down. Are you getting your 2 to 10, 0 to 10, 4 to 20 signal to your actuator to go up and down? If you're not getting your signal, then go to the controller itself. Take the wire off, test the output. See what the output is doing. If your output is working and you connect your wiring back up, then what we like to do is we like to take the wiring off of the actuator and then verify the voltage going into the actuator, because there are times that an actuator, you may be sending a signal, but then by the time it might give you a funky reading because the actuator is bad itself internally and might be shorting. So it's just doing the process of eliminations, not getting overwhelmed when you look at something because of the fact that you see 100 different wires, things like that. Take it piece by piece by piece. Just like if you were following a schematic on an RTU, an air handler, things like that, VFDs, all that good stuff. So I'm just going to end this first video with a real simple program. Like I said, there's more in detail that we can go, and we're going to build upon on this. So I'm just going to call this chill water air handler option 1. And then, like I said, then we can build upon it. I'm going to show you guys how to check your PIDs, verify that your PIDs are in the right direction. And then we can modulate from there. We could take this outdoor air damper, look at space or return CO2, modulate our CO2 based on, or modulate our outdoor air damper based on CO2. So that way you're not opening your damper 100% when there's no need for it, when everything in the background is doing well and you're not bringing in all this humidity. So like I said, thanks for listening. Please leave a comment. We're here to help. If there's something particular you'd like to see, graphics, any of that, any kind of situation, please message me. Let me know what you guys would like to see. We're here to help everyone. This is to I know there's some things out there, but there's not a lot for us out there when it comes to the technical. Like I said, if there's something that you want to see, make a comment, message me, shoot me a picture, and then I can bring it on and we'll show you how it works. So thanks for listening. Hope you guys found this pretty informative, and I appreciate your time. Thank you.